Hi dear. So last class we have seen about the application of heating effect of the electric current, right? So today we are going to learn about this electric power and electric energy. Okay. So once you recollect what you have studied in class 9, what is power and energy, then it is very easy for you to learn this what is electric power and energy. Okay. Power means that rate of doing work, right? Rate of doing work or rate of transfer of energy or rate of consumption of energy. That is energy means capacity to do work. Okay, at what rate it is, whether it is they are doing a very slow manner or fast, that rate of doing work is nothing but your power, right? So power is equals to work done by time taken. In particular time, what is the work done? Okay, that is the power. So unit of power is what you know, that is 1 watt is equals to 1 joules per 1 second. Okay, 1 joule of work done in 1 second, right? Sorry, 1 joule of energy consumed in 1 second. So 1 watt equals to 1 joule per. This we have studied in 9th standard. Okay, so here same thing. Power means what? Rate of doing work, that is consumption of energy or transfer of energy, same thing. Okay, so electric power means it is defined as a rate at which electric energy is dissipated or consumed in an electric circuit. Okay, that is the definition of electric power. Electric power is nothing but the electric energy is dissipated or consumed in an electric current, the rate at which it is consumed or dissipated. Okay, it is given by P is equals to V into I. Here this how much energy is dissipated, you know that based on the potential difference created, that much the potential difference gives the that much of energy is carried by each coulomb, right? For example, this is your resistor. Okay, for example, current 3 amp current is flowing here. Okay, that means 3 amps means what is it? 1 ampere equals to 1 amp equals to 1 coulomb per 1 second. Okay, per second how much charge is moving. Okay, right? That is the flow of charges per second is your current, right? So here it means per second 3 coulombs of charge is moving at this circuit, right? Here only the energy will be dissipated or consumed, right? Here in the flow, the energy will not be lost. When it crosses the resistor, then only energy will be lost, right? So 3 amps current is flowing in this circuit means then 3 coulombs of electrons is flowing through per second in this resistor, right? So how much energy it dissipated or how much energy is lost here is given by the volt, right? The potential difference between this point and this point would be, for example, 5 volt. Okay, that means volt means what? Work done in moving a unit charge from one place to another, from here to here. How much amount of work done takes place, right? Work done in bringing this charge from here to here. Okay, that would so bringing 1 coulomb here, charge means what is it? Coulomb. How much energy is required? 1 joules, right? So to bring 1 coulomb of charge, it requires 5 joules of energy, right? 5 joules of energy. So 5 joules of energy will be dissipated or 5 joules of energy will be dissipated here, right? So for 1 coulomb of charge, 5 joules of energy is dissipated, means for 3 coulombs per second, 3 coulombs are moving, right? So 5 into 3, that is equals to 15. Okay, 15 joules per second. Okay, 15 joules per seconds of energy will be dissipated here. Clear on this? That's why it is given as P equals to V into I. V means what is that? V is given by work done by moving a charge, right? Moving a charge from one place to another, one point to another. Here current is charge divided by moving the flow of charge per unit time, right? Unit time means T. So here the work done is given by joule. The charge, unit of charge is coulomb. Here the unit of charge is coulomb. Here the time is given by seconds. This get cancelled. This is equals to joules per second. You know that 1 watt is, the unit of power is watt, and 1 watt is equals to 1 joules per 1 second. This is how it has come. Power equals to VI. Okay. V is nothing but the potential difference, and I is your current carrying. Okay. 3 amps current is flowing here means how much energy will be dissipated. 1 cool to move a charge, 1 unit of charge, it requires 5 joules of energy, 5 joules, right? 5 joules of energy is required. So for moving a 3 joules of 3 coulombs of charge, it requires 5 into 3, 15 joules per seconds of energy will be required, dissipated, right? So if it is given in the form of volt and current, you can use this formula. If in case volt is not given, resistance has been given means you can go for this formula. You can substitute V equals to IR from Ohm's formula, right? V from Ohm's law. V equals to IR. So you can rewrite as I square R. P equals to I square by R. You can go for this formula. P equals to I square R when R and I is given. Okay. You can go for I and if they given I and V, you can go by this formula. Okay. In case they are given only volt and resistance, then you can go by this formula. You can use this I square again in terms of from the Ohm's law. I equals to what? V by R. So I square equals to V square by R square. R get cancelled. So V square by R. So whatever in the numericals they are given, based on that values you can go for any of these 3 formula. Okay. V and I is given means you can go by this. I and R is given means you can go by this, and V and R is given means you can go by this formula. Okay. Okay. So the SI unit of electric power is watt. Okay. Joules per second means SI unit of electric power is watt. Again, what is 1 watt? 1 watt is, in terms of electric power, it is a power consumed by a device that carries 1 amps of current when operated at a potential difference of 1 volt. Okay, when 1 amps of current when operated at a potential difference of 1 volt. Okay, that means 1 amp is moving means 1 coulomb per second is moving across the resistance, and how much energy is given? 1 volt means 1 joules per second, right? So per coulomb. So V into 1V into 1A equals to 1 watt. 1 watt equals to 1 volt into 1 ampere. Clear? If you thorough with this basic formula, what is power, then you can rewrite in the form of in terms of electric energy. Okay. So what we have learned, what is electric power? Power is given by, electric power is nothing but the rate at which electric energy is dissipated or consumed. So P equals to VI, or we can write P equals to I square R, or we can write P equals to V square by R. Based on the given values, you can use any of this formula. And the SI unit of the electric power is watt. What is 1 watt? 1 watt is nothing but the power consumed by the device that carries 1 amps of current when operated at a potential difference of 1 volt. Clear? So the smaller unit of power is watt and the larger unit of power is kilowatt. 1 kilowatt equals to, if it is mentioned kilo means 1000 always usually. So 1 kilowatt equals to 1000 watts. Okay. Likewise, we'll go for the energy. If you know what is energy and what is its unit, then we can relate with the electrical energy. Okay. What is energy? Capacity to do work is called energy. What is the SI unit of energy? Capacity to work means what much energy is required. Joules. The SI unit is joule. You know that power equals to, what we have learned, power equals to work done by time. Work is nothing but energy consumed here, right? Energy consumed. So we can rewrite that power equals to work by time. Instead of work, we can rewrite as energy. Power equals to energy by time. So we are going to calculate energy only here. So we can keep the energy here, bring the time to this side. Okay, so energy equals to power into time. Okay, so power into time. So what will be the unit? What is the unit of power? Watt. Time is seconds. So unit of power is, sorry, unit of energy is watt seconds. Okay, watt seconds is nothing but your joules. Okay, joules, because energy, the unit of energy is joule. Okay, so likewise electrical energy, it is the product of the electric power and time. Okay, so energy E equals to power into time. Okay, the SI unit of electric energy is watt hour, because what is the unit of power? Watt, and they will not usually measure in seconds, so we'll go for the time. Time is calculated only per hour, so time they will usually taken for 1 hour. Okay, so watt into hour. So SI unit of the electrical energy is watt hour. Okay, so how will you define 1 watt hour? 1 watt hour equals to, it is the energy consumed. What is it? Energy consumed when 1 watt of power is used for 1 hour. When 1 watt of power, 1 watt of power is used for 1 hour. Okay, then we call it as 1 watt hour. Okay, it is energy consumed when 1 watt of power is consumed for 1 hour. Okay, usually for the commercial purpose we will not use this smaller unit. Watt hour is a smaller unit. We'll go for the bigger unit, that is your kilowatt hour. Okay, instead of watt hour we'll go for the kilowatt hour. Usually we'll call this kilowatt hour as unit. Okay, in common use in the electricity in our home, you can see that how many units are consumed. The electricity person will come and take the readings, right? So 53 units have gone, 100 units have gone, 200 units have gone. That unit, 1 unit means 1 kilowatt hour. That means what? 1 kilowatt hour is nothing but your energy consumed. Okay, so we are only paying for this much unit as gone, means this much energy has been supplied to us. Okay, supplied to our home. We are consuming that energy to move an electron. Okay, so the commercial unit of electric energy is kilowatt hour. It is commonly called as unit. 1 kilowatt hour equals to 1 kilowatt equals to 1000 watts. So in the hour, if you convert into seconds, means we are just giving the value. 1 kilowatt hour means how much actually it would be. Okay, in terms of joules we are trying to give. Okay, so you're converting the kilowatt hours to watt and hour to seconds. Seconds means converted into, multiply by 60 into 60 for converting to minute, and then to seconds. Okay, 60 into 60. So it can be rewritten as 3.6 into 10 to the power of 6 watt seconds. Okay, what is your watt seconds means? What? Nothing but your joule, right? So 1 kilowatt hour equals to 3.6 into 10 to the power of 6 joules. Okay, so this much energy is consumed. Okay, 1 kilowatt hour equals to 3.6 into 10 to the power of 6 joules. Okay, so last class I told you that for which domestic use or commercial use will go for which rating we will be using, that is the fuse, right? Usually it is rated as 1 amps, 2 amps, 3 amps, 5 amps, 10 amps, like that. Okay, which fuse you will use for your purpose. Okay, for example, you are going to use a electric iron. Okay, going to consume 1 kilowatt power. Okay, 1 kilowatt power is going to consume by that. Okay, power is going to consume by that, and you are supplied with 220 volts. Okay, 220 volts potential difference is given, and it will be consuming 1 kilowatt power. Okay, what will be the current? You know that power equals to V into I. Okay, so you know that power is 1 kilowatt hour, so that will convert it into watts. 1000 divided by 1000 divided by I equals to P by V. So 1000 divided by volt is 220 volt. 4 times 4 it comes around 4.54. Okay, 4.54. So the current supplied for this electric ion is 4.54 amps. Okay, so it is enough to supply 4.54 amps for this electric ion. Okay, so based on this only, because H equals to I square RT, right? So it is a directly proportional square of the current supplied to this electric gadget, right? So how much heat will be produced based on the amps, right? Current flowing through that. Okay, so it is enough to have 4.54 amps for this electric iron to work. Okay, that much heat energy will be dissipated there. If you supply more than this gadget will start burning because of the energy dissipated. Overheat, temperature will increase, the gadget will burn. Okay, to stop the flow of current, so we are, since it requires 4.54 amps, we'll go for the 5 amps fuse. Okay, we will fix a 5 amp fuse in series with this electric ion. Okay, if more current is coming, this fuse get heated up, temperature will increase and it will break down. Okay, no, there is no flow of current, then the gadget will be saved. Okay, clear? This is how you will be choosing the fuse, whether it is 1 amps or 2 amps or 3 amps fuse has to be used. Okay, based on your gadgets or how much current is required, based on that only we will be choosing the fuse material. Okay, yeah, thank you.